G'day guys, today's video we're going to be looking at the sine rule, but in this case we're going to be looking at finding angles. Now you'll find what we're going to do here will be almost exactly the same as what we did in the other one, but we've got an extra step. Now the key thing here again is actually being able to identify corresponding sides and angles. Alright, so I think we can do that by simply doing that. Yep, we've got corresponding sides and angles, and we've got one unknown. Alright, now the same process here is make sure you put your unknown on the top left hand side. In this particular case, it's an angle, so we're going to go sine of theta to the corresponding side is 10, is going to be the same as sine of 80 degrees over 12. Now, the same process, because we're dividing by 10 on that side, we want to get rid of it. We have to times by 10. So sine of theta equals 10 sine 80 degrees all over 12. Now, we want to work out our angle theta. So our angle theta is inverse sine of 10 sine 80 degrees all over 12. All right. If once you get really good at this stuff, you could possibly skip that step. You could skip that step, okay? Now, this is where we go to our calculator and we work out our answer. All right, so we're going to do that one step on our calculator. All right, so that's going to be inverse sine of 10 sine 80. Now you're going to close that bracket and divide that by 12, and then close your bracket, and that's going to give me 55.15 degrees or 55.2 degrees. That's good enough for me. So that's 55.2 degrees. Now, does that sound reasonable? Well, we know 12 should have the biggest angle, so we're looking for an angle less than 80 degrees, so that makes sense to me. Right, same process. Okay, over here we're looking for an angle, so again we put that on the top left hand side. It's an angle, so it's sine of alpha all over corresponding side. Let's identify those. Okay, and then that one over there, just so we get them right each time. So corresponding side for alpha is going to be 4 meters. And then we got sine of 70 degrees, and that's going to be corresponding side is 3. Right, it's important that you show that substitution. Now, if I want to skip to the next bit, I could go alpha inverse sine. I know I'm going to do that. I know the 4 is going to go up to the top line. Sine of 70 degrees all over 3. Now, if you need to write the other step, that's fine, no problems. I'm going to give you a mark basically getting to that point there. Substitution, rearrangement, and then getting your answer. Okay, go to the calculator and we're going to do that in one step. So inverse sine, shift sine or inverse sine of 4. And that's going to be sine of, I can't remember the angle. Let's go back to that. Bad memory. Sine 70 over 30. Okay, so sine of 70, close your bracket, divide that by 3, close your bracket, and that gives me, now let's go to that. Have I done something wrong here? Inverse sine. Now, the thing that this may be the case, it may be that the angle is actually it doesn't exist. Okay, that triangle can't exist because the sides are too long. So that's generally the case in this thing over here. Let's change the relationship. Okay, let's make the longest side 3, or that one over there, and see if that works. And that's going to work. So if I change the diagram around, that would actually make, that's 44.8. And all I'm going to do is I'm going to change these things around in here to make that work. Alright? Because obviously it doesn't exist in that relationship. All right, so again, if I change that in here, so obviously the ones that you're going to get in your test will all be sorted out for that to make sure that they actually will work. All right, because that meant probably the angle had to be, you know, like 90 degrees or something like that, and then that wouldn't be possible, that triangle. So if the triangle's not possible, then it won't work out. Now, if I was looking at this side, because that side is smaller than the 70, then we know that that angle should be smaller as well. All right, so the process is a really simple process, the same as the other one. You've got one extra step where you've got to actually do your inverse sine. I quite like that setting out there. I think that is, you know, when I'm doing my sine rule stuff, working at an angle, I actually like that process. All right, sometimes it's good to make a mistake because we can learn from that. If you always got the right answer and you never got a scenario like this triangle where it was wrong, then, you know, you would not know what to do. So chances are, you know, most of these will work for you, but, you know, hopefully that makes sense.